wabarakatuh. We'll continue with our revision for Unit 1, Forces and Motion. The other concept we studied, the acceleration. What do I mean by acceleration? The acceleration is the rate at which velocity changes over time. So I should have acceleration if I have a change in velocity over time. Change, it means the difference between final velocity and initial velocity. Initial, it means the beginning velocity over a change in time. Acceleration is a vector quantity, so I have to specify as well the direction. I can find the unit of acceleration from the formula itself. Unit for velocity is mass per second over second. So I can write it like that. I can write it as mass per second or mass per second square. From here, I can find the velocity. Acceleration times time. I can find the time, which is velocity over acceleration. If I draw velocity versus time graph, the slope of velocity versus time graph will give you the acceleration. Here, I don't have a change in the velocity. The acceleration here is 0. All the time it's constant velocity. So constant velocity, it means acceleration 0. Here still, acceleration 0, but the object is traveling in the opposite direction or backward. I can see it's traveling backward or in the negative value. Here, I have a change in the velocity. So the acceleration is constant. How can I find the value of this acceleration? It's rise, the slope. Rise over run. So the acceleration, it gives you the slope of what? Of velocity versus time graph. Velocity versus time graph. Here I have change in the velocity, but the velocity is decreasing. Start, for example, from 10, and here it become, for example, 7. Decrease in the velocity, it means I have deceleration. But still the object moving forward with negative value. The other concept also we've studied, how can I use kinematic equation? Kinematic equation, I can use them if I have constant acceleration. So for constant acceleration, I can apply uniformly accelerated rectilinear motion or kinematic equation. Kinematic equation. This equation, you have to know them, or at least know how to apply them. So the first formula, distance or displacement equal average velocity. This is V average times time, and we know distance, it's V times time. I need to find V final equals V initial plus acceleration times time. This one is from acceleration. We said acceleration, it's velocity, change in velocity divided by change in time. So if I need the velocity, it's acceleration times time. Acceleration times time plus V initial. I need distance or displacement. Distance or displacement is velocity times time. So V initial times time plus half a delta t square. If you verify the units for mass per second square times second square, this unit, it will give you the unit of distance, meter. So this formula is correct. V final square equals V initial square plus 2 acceleration times displacement, and this we call it timeless equation. I can use it if time is not given to me in the question. How can I apply these formulas in questions? Depends on the question. Like here we have a question. Here you have a cat, and the cat is pushing a plastic ball rolling towards it at 20 centimeters per second with its nose. Okay, so the cat, here is the cat, is pushing a ball towards it. pushing the ball toward it. This is the direction. Displacing the ball 10 centimeter in opposite direction. So the ball will move in the opposite direction. Delta x is 10 centimeter. Here, the initial velocity, this one represents V initial. I'm going to put negative because velocity is vector quantity. We agreed right is positive, left negative, up positive, down negative. So left it will be negative 20 centimeter per second. In 5 seconds, so here I have time, delta t, 5 seconds. Always look at the unit. Second is for time. What is the acceleration of the ball? So I need to find the acceleration. These are my given. Second step, I have to check the unit. Are the unit consistent? Here I have centimeter, here centimeter. Yes, my units are consistent, even though centimeter is not SI unit, but they're Gaussian, CGS, centimeter, gram, second. They're consistent. So I have centimeter and second in the Gaussian system. So I'm fine. Okay, I don't need to convert. So second step, all I need to do is just write the formula and solve the question. Since I have time, I can use this formula because I have V initial, I have time, and I need to find the acceleration. So delta x will equal V initial times time plus half acceleration time square, and then apply. Delta x is 10, V initial is negative 20, delta t time is 5 plus half. I don't have the acceleration, so I keep it as it is, a. Delta t square, 5 square. So here I have 10. Here I have negative 100 plus 5 squared, 25. 25 divided by 2 is 12.5 times a. Take this to the other side and solve the equation. So I will have 10 plus 100 equals 12.5 times a. I need a divided by 12.5 divided by 12.5, and then you get a. The final answer will be 0.87 meter per second squared. Don't forget to write the unit. The other concept we've studied, falling object. Now I have two scenarios. All the object, whether you throw them up, like this one if you have a ball and you throw it up, eventually it will speed up. You see I throw it up with high speed, so V initial is high. And then what will happen to the speed? The speed start to decrease till it reach a point where V final 0. And then it fall down again. When it fall down again, it will start with initial speed 0. And what will happen? You see it's accelerating. Okay, speed is increasing. It will reach the maximum speed just before it hit the ground. Motion upward, like throwing up here, like in this case, upward, everything is positive. So velocity is positive. Distance is positive. Here, in this case, I have object that is falling down or drop. The object is dropping off down. Everything is negative. So the velocity is negative. Delta x is negative. In both cases, I have acceleration due to gravity g, which is equal 9.8 in both cases, or 10 for simplicity. I can assume it's 10 is negative because acceleration always down toward the ground. So g always negative. The value of g negative. I can consider it negative 10 meter per second square. Okay, let's solve practice problem on this one. You have Ahmed. Ahmed throws a ball vertically upward from a roof of a building. The best case is to draw. So I have a building. The height of this building, 10 meter. And Ahmed, he threw the ball upward. Throw it upward, like that. The ball rises and then falls. So it will go up and then it will fall back again here. It just misses the edges of the roof and strike the ground. If the ball in the air is 6 seconds, so this is a time, what was the initial speed, V initial? We said if I throw the ball up, I will have V initial, its maximum, high. So V initial, I don't know, it has a value. Okay, since I have time, I can use the other formula, which is this one, because I have time. So I can write the formula and apply it. Delta X equals V initial delta T plus half acceleration delta T squared. After I wrote the given, next step, I should check the units. Are the units consistent? Yes, I don't need to convert. Everything is fine. Just substitute. Delta X, this is moving down. The ball is raised up and then moved down. So delta X, I'm going to put negative because we said down, anything down, negative. Delta X negative, velocity is negative down. If it's moving up, everything is positive, except acceleration. So it's negative 10 will equal V initial times X plus half. Acceleration due to gravity, G, is negative 10 times 6 squared. Solve this equation. After you do it, you will get here negative 10 will equal V initial, 6V initial minus 36 times 10, 360 divided by 2, 180. Take this to the other side and solve it. So I'll have negative 10 plus 180 equals 6 VI divided by 6 both sides. You will get V initial 28.3. Don't forget the unit, meter per second. Meter per second. We'll continue, inshallah, the last topic, which is forces, in the next video.